This is rewriting a robotics code base in 2025, and yep. So I'm Nico Somers. I'm the software lead of FRC 971. That was our robot this year, and I'm going to talk about the new software stack that we've been working on. So as some people might have noticed, our public GitHub repository for our robotics code is currently read-only, and you might be wondering why it's like that. Okay, so to give some context, in 2011, the software team decided to start a project called AOS, or Autonomous Operating System. And this was basically a framework for the robotics code, and I'll get a little bit more into it in the next slide. In 2019, AOS was fully rewritten so that it would have better logging and replay features, as well as some improved message serialization stuff with Google Flat buffers. AOS has been used for the team for over a decade. So to talk more about AOS, it was a middleware written in C++, which basically means it kind of connected the hardware of the robot sort of with the higher end code that we were writing. And it basically gave real-time guarantees, meaning the execution time and latency were guaranteed. And it ran basically through a publish-subscribe system, which could transfer messages between multiple processes. AOS also utilized a 200 Hertz event loop for all of the signal processing controls, basically everything that we were running on the RoboRio. And eventually we would also use this event loop on the Orange. So as you can see, pretty cool. Although AOS is great, for basically writing the robot controls and code software, teaching new students with it was could be difficult because it had a steep learning curve, and we didn't have great docs for it. And because of that, there was a small amount of recruits every year. Until last season, though, these issues were pretty manageable. Some of the software mentors left, and what that led to was students were basically given students had to maintain basically legacy code by themselves, meaning there was a lot of code that students had to maintain that they didn't, fully didn't understand completely because all of the code was custom written. And there was also some things like Swerve, which the students had to write last year, because our robot last year had a Swerve drivetrain, and writing the controls for Swerve and position estimation was pretty hard by ourselves, so that posed another challenge. And then finally, writing autonomous custom was another thing that was another factor that played into the difficulties that we had with basically the old code base. So in general, there was a lot of time that students spent on features that most teams just get out of the box, and especially teaching new students, this was hard because we had to kind of juggle between writing the custom code ourselves and teaching the new students, which was a pretty daunting task, assuming that we didn't have that many members in software to begin with. So the software team essentially had two options, which were to work on AOS even more, or to make it more sustainable for the next season, or switch to what was more widely used in FRC. And we ended up eventually concluding that switching to what was more widely used was the better decision. Okay, so to make the switch, we had to first do research on what most other teams were using, because we had no prior experience with any of the common tools. We used some public libraries a little bit in the AOS, but a lot of the stuff that we did was custom written. So Autonomous, Swerve, Vision, most of the things we did were custom. So we needed to kind of research and look into what was the popular options for the different aspects of the code base. And so we created kind of this Google sheet here that I put in the slideshow, and we kind of just listed every single option for everything, and we kind of weighed the pros and cons of each one against each other. So after doing our research, we settled on a new code structure, which I'll get into more detail in the following slides. For one, we switched over to GitHub for basically our version. Okay, so in the past, we used Git for version control, but we self-hosted basically the repository in one of our own servers. And so we outsourced that now to just GitHub. And that makes everything a lot easier because we no longer need to basically SSH or connect into one of our own servers whenever we want to like make code changes. I mean, one of the things we had in the past was new members needed to be able to connect to the server from their laptop, and they had to SSH set up and everything. But with GitHub, it's just a lot easier. And we also use Java WPILib now. So WPILib is kind of like the library that most teams use for writing their robot code, and we use it a little bit in AOS, but now we kind of rely heavily on it for a lot more things, rather than just like the very low level stuff. And we also use, just in general, less custom control algorithms now. So we rely on CTRE swerve generator and CTRE motion magic for the swerve and superstructure, respectively. And for vision, we use photon vision, a fork of photon vision. So that's less custom as well. And for logging and simulation, we use Advantage Scope and Advantage Kit. Other non-code related changes we made to the software team were we now have sub-teams and training, and I'll kind of get more into everything here in a bit. Okay, so firstly, we moved from our originally C++ code base, which was AOS, to the Java WPILib code base. And this had a few benefits, which was now the Java WPILib, it's maintained, it's open source and it's maintained by a community. So there's a lot better documentation and it's easier to teach new members about it. There's also just a lot of functionalities we get out of the box instead of having to kind of create ourselves. And it also lets us vibe code. So yeah, and also as I mentioned earlier, we now use motion magic for controlling our mechanisms, which in the past we kind of had a custom control algorithm for controlling both swerve and the superstructure. So we now have those kind of outsourced in a way so that we use CTRE's tools to control the mechanisms on the robot. Okay, so for vision, vision is no longer entirely custom. We run photon visions on the Orans, which we did use in the past for our custom stack, but we're kind of reusing now just with more open source software. And to get these to work, actually, with the current hardware we already had, we had to do some custom things, such as we had to add drivers for the MIPI cameras that we use. And we also decided to use the same April tag detection algorithm we were running in the custom stack. So to implement that also took some custom coding. But what that did is it allowed us to reuse a lot of the same hardware with like less code we needed to maintain ourselves. And in the future, we're also looking towards other options, such as Limelights or possibly a full custom vision stack. Okay. For autonomous and autoline, instead of doing full custom like we did in the past, we now use Path Planner and are looking to use Choreo. And for our autoline code, we now use just a translation PID and a rotation PID for that. And yeah, it's pretty commonly used. Okay, now into the subteams. In the past, I should have mentioned this, but in the past, software basically used to be one lead with pretty much everyone else kind of like directly under that one lead. And now we've changed that. So we still have the overarching lead, but we have kind of sub-team leads who take charge of specific areas within software. So this way, work is more evenly distributed between all the students in software. And because people are more specialized in like one category, we have code coming out faster and also just better code because people kind of have more experience in that one area, so they become really good at that one thing. For training, unlike the past, now we kind of have more structured training for newer members. So we have a whole GitHub repository just for training new members, and there's 3 tasks that they need to complete within the repository to basically earn their way into kind of being able to work on the 971 code. So each of these 3 tasks basically demonstrates their knowledge in Git, Java, WPILib, how subsystems work, how controls work, and it gives students kind of a really structured way of being introduced to the code base. Oh, and here's a video of the robot with the new stack. I'll let the full auto show. Okay. So yeah, that's the new code base. Okay, so here are the pros and cons of switching from our more custom C++ code base to the Java WPILib. So the cons of the switch, we now have less complicated control algorithms, and that can be seen as a con since now we have a lot more tuning to do, and yeah, it's sort of, okay, I'm blanking. Yeah. The WPILib command scheduler is not necessarily deterministic and runs at 50 hertz, and that just means sometimes we get command loop overruns, and that means the command loop isn't running at a set frequency consistently. Sometimes it overruns its command loop, and we didn't have that with the AOS stack. And there's also kind of less learning about more in-depth concepts because we now outsource that to external libraries. So there's less learning in the more advanced areas. And just in general, it's less customizable code because we are relying on more open source software for our code base. Okay, here are the pros of the switch. Now we have less code to maintain ourselves, so we can focus on instead of focusing on the baseline aspects of the code base, we can kind of focus on the higher level stuff. It's also easier to debug because, yeah, we just understand more, and there's an easier learning curve for newer members. Also, just documentation is widely available for the stuff that we're using now, so we don't have to worry about not understanding how something works or something not being well documented by whoever created it. And as I mentioned earlier, we can spend more time working on higher level code and training in general, just training up our newer members. Okay, here are our future plans for the Codebase stack. So we want to kind of refactor our superstructure code right now to be basically easier to use because our superstructure is currently modeled after another team's code, I believe 119, and we want to, or 190, sorry. It's currently modeled after 190's code, and we want to kind of refactor it in a way so that it makes more sense to us and is easier to use. We also want to change our vision stack to Limelight's or a custom stack in the future, and just so we could have easier to use and better vision. And we also are looking into better simulation and logging features for the code base. So main takeaways is our old stack basically became unsustainable. Due to this, we had to research and create a new code base, and our current code base is now more sustainable, and we're still adding changes to it. And questions, if anyone has any questions, leave them in the comments. Thank you.